Hello everyone, welcome to Automation Community. In this session, we are going to see about retentive timers. Before entering into the topic, kindly like and subscribe our YouTube channel for more updates. So in CX Programmer, we have two type of retentive timers. So one is TTIM and TTIM next. So both works same, but this is a BCD type timer and that is a binary type timer. So here is the timer number and the timer number must be between these value, and we have a set value range here. So for BCD this is the range and for binary this is the range. Okay, so without any time delay we'll go to the CX Programmer and see how to work with these two timers. So TTIM and TTIM next. Let's open a same example. So I have here TTIM. This is called as totalizing timer. So retentive timers are called as totalizing timers here. So click OK and give the timer name here 0. And here you can give the set value directly here, or you can give OK and you can edit there also. So I'm going to give here for this time. I'm just giving 100. Right? So once you click on this, you are getting a one more input here. So all retentive timers are having a reset option. So a timer is having a two inputs are there. One is for turning on the timer and another is for resetting the timer. So what I'll do, I'll just add one more input here to reset the timer. So 0.01. So all retentive timers will be having a reset option. So go for this. So I'll edit this. Alright. So let's go online and check this BCD type first. Then we will go for binary type. So let's turn on this. So after 10 seconds, your output is on. Right? So this totalizing timer is like counting from low value to higher value. Okay. So why it is counting from lower value to higher value, I'll tell you. See, even though if you turn off the timer value, your output is not turning off. That is a feature of totalizing timer. So you have to use the reset option to turn off. See, once you turn on the reset input, even your set value is going to 0 and your motor is also off. So that's the working of retentive timer in Omron. So I'll repeat again. I'm going to turn on this. Okay, so after a time delay, your output is on. So you are turning off your input. So in the previous 6 timers, in the previous session, we have seen the types of timers. So in those timers, if you turn off the input, your output will also go off. But in retentive type of timer, the totalizing timer in CX Programmer will not work like the same. So you have to use one more input to reset this. It is like a set. So once the timer is turned on means it is like a set coil, and after that obviously you have to use the reset option to reset the timer and also your output. So I'm going to turn on this to reset. That's it. We have done the reset. So one more thing. So let it be running. We'll turn off in between. So it started increasing. I'm going to turn off in between. So look at this. What is happening? Your value is retains. Right? So previously what will happen? It will go back to the original value. So now where you got stop. It is returning over there. So let's turn on again. And it started running from the place where it left. Correct? So that's what it is retaining the value. No, that's what it is called as retentive timer. So let's add that binary type also. 0.00 TTIM X timer 1 and I'm giving the value same as that. That's it. Okay. And I'll have, this is also having 2 legs. So I'm adding the same reset coil input and I'm connecting it. Right. And we will have one more input to turn on an output. Right, so it's connected. So let's compile this. So we have an error. So what is this error? Look at this overlapping runs. So in overall, if you are using a timer, that should be in one run only. You cannot connect one more output along with this. Look at this. This is having at 0th run and the motor is at next run. And this is at second run and this have to be in the next run. So just cut and paste it in the next run. That's it. Now we'll compile. So there is no error for online. Alright. So turn on. Both the timers are started running. If you turn off in between, both are holding the value. Correct? And if you turn on again, it will start from there. And once the time delay is done, it will turn on a motor. So the first timer is turning on this motor and the second timer is turning on the another motor. See, I have not turned on this. So look at this. This output is not turned on because I have used some other input. Instead of using the timer number, I have used some other input. That's what this is not turned on. Okay. So if you turn on the reset, what will happen? So if you turn on the reset, your timer is getting reset. So we'll edit this one. Okay. So let's run again. Turning on, both are running. So after that, motor 1 and motor both will get turned on. See, it's turned on. See, now the input is on. Okay, if I reset, what will happen? It got reset. Okay, but you just turn it off. That's it. Again, it will get turned on. The timer will again get turned on because your input is still in a on condition. So I'll repeat again. Both the outputs are on. No. So now before turning off the input, I'm going to reset. So now the reset bit is on. So your set value is going back to the previous original value. Okay, the starting value. So now you are going to turn off your reset. Since your input is in on condition, it started running. The timer is again start. So this is the working of retentive timers, and all retentive timers should have a reset input. I hope you have understand the concept. I'll meet you in the next session with another interesting topic. So before that, Kindly like and subscribe our YouTube channel for more updates. I'll meet you in the next section. Thank you.